Hi and welcome. I'm trying to learn biochemistry. Today, solutions, colloids and suspensions. And after we've done with, we're going to do shoulder impingement training. And if you participate in the shoulder impingement training, then it's at your own risk. And this is part 4 or 5 of colloids, solutions and suspensions. And we're talking about internal anatomy. Now, we had done already our presentation about mixtures. What mixtures are? Mixtures are basically, what I said was that things are physically fused together, but they did not form new chemical bonds, not a new element. That is, they are just mixed together. And now there are solutions. And in solutions, the solute is in the solvent completely dissolved. And it's also translucent, so it's clear, like sweat. Where salt, the solute, is dissolved in the solvent of water, and it is clearly visible through it, it's translucent, and also it is evenly dispersed, and it stays that way. Now to the colloids. A colloid differs from a solution mainly on the basis of the size of its particles. The solute particles in a colloid are large enough to scatter light, just as water droplets in a fog scatter light from a car's headlight beams. For this reason, colloids usually look translucent or opaque. So they look translucent, and not over, but translucent. It does not. Transparent means to look through, and translucent not. Milk is an example of a liquid that is both a colloid and a solution. The large milk proteins make it a colloid, whereas calcium salts, milk sugar, lactose, milk sugar, which is lactose, and other small particles are in solution. In both solutions and colloids, the solute do not settle out it is called, and accumulate on the bottom of a container. Okay, colloids. They are translucent, the other one are transparent. Colloids, there are larger particles. Are they also called solute? This is not written here. There are no larger particles in it as in a solution. Maybe we're going to explain first what a solution is. There are larger particles in it, like for example milk, and it is not translucent or opaque, it is not through visible. But colloids and suspension, they both does not settle down or settle out to the ground. I think that is all. And milk is both a solution and colloid, because the lactose, the milk sugar, and the milk sugar and the calcium salts, they are completely dissolved. But you have a finger. I'm going to start the camera and try to save it. Colloids. Colloids are a form of mixture. They are different ones. They are, for example, solutions. And in solutions, where the solute, like salt, is in the solvent, water, completely dissolved, and it's evenly dispersed and transparent, and it does not settle down. Colloids are similar, but there are larger proteins in it, so that it is not visible through it like in solutions. They are translucent, they are opaque. For example, milk. Milk is both. It is a solution because the calcium salts and the milk sugar, the lactose, they are completely evenly dispersed into the milk, into the water, I think. But there are also colloids. In colloids, the larger milk proteins in milk are not transparent. You can't see through milk. It is white, it's opaque. You can't see through it. But they don't settle down as it is in suspensions. So, solutions, evenly dispersed, does not settle down, visible through it. And now, colloids, where you can't see through them, there are larger proteins in, like in milk. The milk proteins, milk is both a solution because of the calcium salts, completely dissolved, like the salts in sweat, with the solutions. But in colloids, they are not visible through it. In suspensions, they are like blood, where they slowly settle down. So, colloids, now settling down, evenly dispersed, but not visible through it like in solutions. That is according to Gerard Tatoga and Sandra Grabowski's Principles of Anatomy and Physiology book, page 38. But this is not medical. I'm going to stop the camera. And we're going to go to the next thing, the suspensions. In a suspension, by contrast, the suspended material may mix with a liquid or suspending medium for some time, but eventually, now we're going to talk about blood, and eventually settle down. Blood is an example of a suspension. When freshly drawn from the body, blood has an even reddish color. After it sits for a while in the test tube, the top layer appears pale yellow. This is the liquid portion of blood called plasma, which is both a solution of ions and other small solutes and a colloid due to the presence of plasma proteins. Red blood cells that have settled out of the suspension drift to the bottom of the tube, making the lower layer look red. Okay, blood, the liquid is on top, the plasma, it is yellow, at the beginning it is red, the yellow, and that is both a solution and a colloid, a solution, because the ions and other things are completely dissolved, but also a colloid because of a plasma protein, the other plasma proteins now. But the hemoglobin, the blood cells, they have settled down to the bottom and now it is a suspension. I'm going to start the camera again. Suspension, the type of mixture. Now there are different types of mixtures. There can be solutions and colloids and now suspensions. In solutions, where the solute is completely evenly dispersed and they are transparent, like sweat. The salt has completely dissolved in the water. When there are things like milk, these are colloids. Milk is a suspension, a solution and a colloid. Where in milk are the milk proteins and they make it not visible through it. They are opaque. Milk, you can't see through it, and therefore it is a colloid. It is also a solution because there are lactose, for example, in it, which have completely dissolved, evenly dispersed in the visible fluid, but there are also the milk proteins in it, making it not visible fluid. Now the suspension. In the suspension, blood is an example. Where they settle down, basically. In sweat, they never settle down, the salts, they completely stay like that, evenly dispersed, and also in milk, in colloids, they stay like that. But in blood, in suspension, it happens differently. It settles down over time. Blood freshly drawn is red, but if you let it stand for some time, at the top there is now the liquid part, the plasma, and that is yellow. The yellow part is a solution and a colloid. There are ions in it, they are completely dissolved, even dispersed like salt in water and sweat. But there are also some other things in it. They have completely dissolved, but they are not like colloids now in it, and plasma is yellow. It is not translucent fluid. But the blood cells, the hemoglobin, they have sunk down to the bottom, and that makes it suspension. So solutions, all stays as it is. Evenly dispersed sweat, and milk also evenly dispersed, but you can't see through it, like through sweat. Colloids and our suspensions, over time it settles down. That is according to Gerard Torvald-Sennegebowski's Principles of Anatomy and Physiology book, page 38, but this is not medical. I'm going to stop the camera. And now I'm actually wondering. Now, I want to do one video more. There, compare all three. Basically, I did it already. Compare all three. But we're going to come anyway back to that chapter for the mode and say how now the concentration of such a solute in the solvent is given. That means we're going to come back anyway to another part. So we're going to make the presentation in the next part, and we have another chance to learn it when it all had settled down a bit. So we can learn it again. That means, if you were here for biochemistry, you can go directly to the next part of biochemistry, where we will probably then the presentation about all three, and starting to work on our presentation about how the concentration of a solute and solvent is measured, with modes and so on, and percentage. Then you can go directly to the next part. If you stay here and participate in the shoulder impingement training, that is better. In the leg standing, good and stable, and we're doing shoulder circuits. Back, up, and front. Back, front, and backwards. Front. And now, long arms, strong fists. Go as far back with the shoulders as you can. High up, front, down, again back, up, and then backwards. Up, back, down, front, up, back. Now, legs a bit wider apart, go down into the knees, hinge forward with a straight back, let the arms hang, pinch the scapulars together, lift effort. Back fists, lift the arms up and still pinch the scapulars together. Arms down, shoulders down. And now, legs a bit together again, and long arms with fists, outside without fists, maybe this time, and turn the arms to the inside, into the rotation, and lift the arms high up and bring them together. Bring the shoulders down and together. So the arms high up, the fist, arms high up and together, shoulders down and together. And release. And now lift. Again, the arms down. Shoulders down and together, but now turn the arms to the inside. Without going back. So shoulders down and together, arms to the inside. And arms to the outside, shoulders down and together. And you try to bring the scapula not just back, but into the ribcage. So into the ribcage. And together. And again, shoulders down and together, and arms to the inside, the fists. And the shoulders down into the ribcage and together. And out. Scapulas down into the ribcage and together. Arms to the outside. And release. Arms to the side. Feet in front, bring the arms in front. Shoulders down and together. Again into the ribcage. Turn the arms in front and shoulders into the ribcage. Arms back, shoulders up and in front. And back. Arms in front, shoulders down and together. Last time back, with the arms up and the shoulders in front. And now, lift the arms up. Do this only if it does not cause pain. Arms up. Arms up. Shoulders up. And no down. One more time. Another pretzel, arms together, into the outside. And this is some diagram. Have soccer t-shirt or something else with a long arm at the outside, let it fall down and try to catch it again. And on the outside. And we're stretching one arm in front, shoulders back, down, pull the arm in, have your fingers, try to relax the arm, go a bit back with the shoulder and turn the palm up to the sky. And the other arm in front, shoulder back, down, pull the arm in, have your fingers, try to relax the arm, go a bit back with the shoulder and turn the palm up to the sky. And that was the short impingement training. I thank you very much, and at least.